Hello, everybody, and welcome to our small but homely event. So, today we have three wonderful guys here, three experts who have, well, several decades of hands-on C++ experience under their belts, and I'm not overestimating anything, right? Right. Okay. So, from left to right then. So here we have Kirk Šup from Microsoft. He is most known for his work on RX, CPP, and several other libraries. Then Жоэль Фальку from Paris Sud University. He's an associate professor there, and he's known for his involvement in C++ standardization and in Boost. If anybody of you have heard about Boost SIMD, then he's the guy. And then we have Gor Nishanov, also from Microsoft. He's known for his work on C++ reasonable functions proposal, and he's also heavily involved in the standardization process. Then my name is Alexandr Fokin, and I'm going to be your host today. I work at Yandex, and I'm responsible for our search runtime. So besides the guys here, we have guys in Moscow listening to us right now and watching us. Hello, Moscow.
Hello, St. Petersburg. Can you hear us?
Yep.
Can you see our hands waving?
Yeah, more or less.
Great. So we're looking forward for today's meeting. We have roughly about 50 people here. We really welcoming you in Russia, and we're ready to ask questions, and we're ready to participate in discussion. Besides Moscow, we have Nizhny Novgorod online. So Nizhny.
Hello from Nizhny. We got almost a full room here, about 30 people, and we also would like to welcome our guests that came from France and the United States, and we are eager. What's new we got in C++ and in the industry.
Cool, thank you.
Welcome.
So I would also like to welcome all the guys who are watching us right now online from the comfort of their homes. I really envy them, actually. So I actually had a plan for this meeting with me somewhere, but it looks like I've lost it on the way. So we will have to improvise, which means I really do rely on the fact that you will ask questions, like Big Brother wants your questions. And, to make it more beneficial for you, we actually have prepared several prizes, which we will hand out in the end of this event to those who have asked the best questions. So I have introduced our experts, but I believe they can say more about themselves. So, Gor, can you pick up the mic? So can you tell us more about yourself, like what you are doing at Microsoft, what your interests are, and how did you end up here?
Sure. But before, несколько слов по-русски. Мы тут недавно репетировали и обнаружили, что если я говорю по-русски, а все остальные говорят по-английски, то не очень хорошо получается, трудно переключаться, и потом Kirk и Joel не могут включиться, так что я буду говорить на английском, так что извините.
Can I do one more technical remark? I'm going to check my phone from time to time because I have online questions here. I'm not playing Farmville, so just bear with me, please. Oh, go on.
Окончил ВМК. Некоторое время работал в Москве, писал программы под Windows. Потом поступил в аспирантуру в Rensselaer Polytechnic Institute. И это оказалось очень счастливым обстоятельством, потому что там как раз работал Дэйв Массер, который вместе с Александром Степановым начали STL. И, в общем, впитавший духа от Дэйва Мастера, и вообще он создал замечательный департамент с большим уклоном на C++. Я решил попробовать применять C++ на каком-то большом проекте, и Windows NT как раз так подвернулось, что туда брали, и я пошел попробовать, и оказалось хорошо. C++ замечательно работает на больших проектах, где требуется эффективность. И проработав Windows NT 15 лет, я накопил достаточно, не то чтобы... Ой, sorry.
Yeah, you were supposed to speak in English, but that's fine.
Okay, you don't know. I'm just telling my bio, so it's boring. В общем... Okay. So at some point, we accumulated enough problems or pains that we had with C++ that we wanted to be addressed. And the top 3 pains were essentially... Okay, sorry, I'm being too long, right? No, okay.
That's fine, please go on.
Okay, I will add more. So essentially, the people, when they switched from C to C++, they actually loved it because we gave them essentially C#-like productivity, but with much better perf. But people were screaming about slow compilation times because it went maybe 10 times from before, because before it was plain C, and now it's C++ with STL and templates. It was very, very slow. People loved the language, but were very sad about how much slower their compilation time goes. Next problem was that, have you seen the errors related to templates where there are many pages and not a single line refers back to your source code? So, and finally, after the switch to C++, we actually got rid of the whole classes of bugs that used to plague our code. Buffer overruns, memory leaks, resource leaks, gone. But we still have bugs. And all of those bugs were in asynchrony. So in my priority list that I cared most, because I think everybody has their own list of top 3 pains. So for me it was asynchrony, figure out some way of making asynchronous programming easier. Second, make compilation time better, and the modules is one of the good things to do that. And third one is template errors. And luckily, concepts are going there. So essentially, we have modules on track, concepts on track, and I ended up doing coroutines, which is a part of the solution to the problem of making asynchronous programming easier and less error prone. And I joined the C++ team 2 years ago, started participating actively in the committee, and I'm still there.
Thank you, Gor. So then here we have Joel. Please go on.
Yeah, so I'm Joэль Fальку. So as Alexandr says, is it working right? Or?
It seems to be working.
Okay. So I'm an associate professor in University of South Paris, and I'm...
Can you hold it a little bit closer?
Okay. I told you I was not, So I'm an associate professor in Paris. I'm also a scientific advisor at Numscale, which is aside this way, right? Okay.
Put it on your chin.
Oh, on
it
the
really
chin.
Works.
Okay, so I will probably learn how to speak in the microphone before I die, but okay. So I'm also doing, scientific advisor for a small company we built on top of my research. I stumbled upon C++ back in the day of my PhD, which was more about parallel programming, and the challenge back in the day was to actually find a way to make parallel programming more productive by not having to, deal with low-level issues, low-level libraries. And somehow we stumbled upon C++ and C++ metaprogramming, and it just clicked that was one of the answers we were looking for. And so since then, I'm actually making new work because I like torturing compilers, using templates, compiling codes for minutes, stuff like this, just so the runtime goes faster. So we work on different kind of code, mostly high-performance computing, and now more like low latency computing, which is basically the same but on different kind of hardware. And we try to port those experience from how HPC is supposed to work on those big machines onto all the new, let's say, small machines that we got everywhere and which are basically as parallel as those big ones. And so we try to, our research is basically about how to do this while keeping, a high level of abstraction that the C++ is actually giving us. And by doing this, I got involved into the French C++ expert pool for the standardization process. It was back in 2011 or something, 2010 maybe, I don't remember. Mostly for the HPC parts, and we try to push some stuff for performances inside the committee. I've been involved in SG1, which is the study group about parallelism and concurrency, if I'm right, yes. And we started looking at SG14, which is a low latency programming study group, which I think has a lot of interest right now in the world of mobile computer and stuff. And yeah, that's pretty much all.
And games. SG14 is about games.
Games.
What about games?
Oh, it's also about games. It's games and low latency computing.
Okay, thank you. And Kirk? Oh, yeah. Forgot about this part. Kirk?
So I started interning at Microsoft while I was still in college, and actually attended the very first C++ class that my college ever provided, and kind of took that to Microsoft and started using that for the projects that I was working on at Microsoft, and that was early 90s. So I stayed mostly in Microsoft. I left for a while, came back, and eventually ended up in a project where I was using C++ pretty heavily, especially the template metaprogramming, in order to reduce the classes of bugs, so that, if you build the tools just right, and I would spend a lot of time on that, and then I would assemble something out of them, and, the result would be that every time I tried to check in a bug, the compiler would scream at me with those wonderful long errors. And so that was kind of my passion for a long time, was building these tools that if you used them in your code, you didn't have to worry about classes of errors. Eventually, I ended up on a subsequent project where we ended up needing to deal with asynchrony in a fairly complicated way, because we were reading 40 megabyte zip files containing XML fragments as individual files. Like each file was a fragment of an XML document. And so we needed to be able to stream this. So we were reading from the front of the file, and we would have to detect that this fragment belonged to a particular document and add that to the stream for that document and decompress it on the fly. And so we ended up with this, and then there were some issues with the XML parser in Windows, so that we had some thread problems where we had to keep the thread stack alive, even though we weren't using that thread right now. And so we had to use user mode threading, and it was a very complex project. And I ended up building something that I later recognized as being completed in a project called Reactive Extensions, which was originally made for .NET. And so a friend of mine started the RxCPP implementation of the Reactive Extensions, and I eventually got very interested in it and started finishing it and trying to make it something that was actually usable. So I've been doing that for a couple of years now. At no point has it actually been a product of my group at Microsoft, so I'm just doing it on my own.
Well, this is cool. So, welcome. Yeah, thank you guys. So, let's talk about C++ finally. What the future holds, because before this event, we have actually asked our guests, to post the questions that they want answered. And the most common thread that was permeating through all these questions was, what is out there? What can we expect? What can we expect from C++ 17? What can we expect after that? And all of you guys are really involved in that. So I'm wondering, can you tell us in more detail? Well, let's first start with C++ 17. Yep. So what you personally most expect, most wait for in C++ 17? What's your most desired for future there?
For me, as I said before, top 3 addressing those 3 concerns. So coroutines, modules, concepts.
So I'm wondering, are coroutines making it in there?
We will know in a few meetings.
In a few meetings, so
because
half a year.
In half a year, probably. If we don't agree that they need to go to 17 in June, it will not go. Same with modules, because essentially the lockdown for allowing features in the C++ 17 is closing very, very, very soon, because 17 is soon
close.
And there have to be some time for national bodies to give their objections or comments, and then the time to respond to them. So essentially the last year will be mostly in those responses to the national body comments. And Russia needs to get a national body, by the way. I know that you're working for it, yes.
Yeah, and by the way, Gor is going right to the committee meeting this Sunday, right?
Yes, I leave in my hotel at 3 a.m. I'm that dedicated.
So I'm wondering, what is going to be discussed there?
We have a lot of work to be done on wording for various proposals. Coroutines will be reviewed by the core working group, and probably need to say a few words how the standardization works. So
yeah, please.
Initially, committee was monolithic, one big thing deciding everything, or at least that's what they told. But then the work became so big, so they split up into core group that deals with, or evolution group that deals with evolution of the language itself, and the library group, which deals with the library part. But then the work became so big, so they split up both groups in 2. So evolution became core working group, which deals how feature fits in the language. And evolution group, which filters all of the crazy ideas that people are coming with. And evolution group is very funny because, they get excited about stuff, and then they'll, yes, let's vote in. And then the core, real serious people will start saying no. Well, sometimes evolution stops too. And the same happened to the library side. So there is the library evolution group where it gets all of the fun and all of the new things. And then the library group, which actually looks at the text and see whether there are any problems and how they fit together. But the work was so big that it was not enough. Then they start making study groups. So we have 14 study groups now, 15. So one study group deals with, say, concurrency, another with modules, another with concepts, another with file system, another with networking. Eventually, when they're happy, they move the proposal to the stage of, say, if it's a language proposal, it'll go into evolution group. If it's a library, it will go into the library group, and then it filters through. So right now, we have a bunch of work that was potentially slated for C++ 17, which is in the core review, and coroutine is one of those. Core group can recommend for 17, but that's fine. Eventually, it goes to national body vote, and how national body will vote, and it's one country, one vote, out of those countries who participate. And it's mostly by consensus. So if one country objects, maybe one country, okay, but if more than one country objects, then it's stopped. But frequently, it stopped even before. So we haven't had a vote to decide whether coroutines will go into 17 or not. But it will be reviewed in core, library, library evolution. And then the same is with modules. Then there will be a vote on whether concepts go in. And pretty much in the evolution group where the crazy proposals, I mean crazy in a good sense, just new cool things that might get into the language, whatever is proposed in the first few days of next week will have a chance to get in. After that, evolution will probably close their doors for any new proposals until post 17, to leave the time for the core group to deal with the fallout of all
We
of the.
still have a chance to submit something, huh?
Yes, it just has to be heard on the first few days.
Oh. Okay. Well, thank you then. Joel?
Well, I will probably say something very close, module and concepts, mostly because of the usability they bring to writing code using complex templates. Module actually solves this, compile time issues.
By the way, feel free to chime in. Because, I don't want to be like a really harsh moderator. Now you have the word and you just shut up. No, I don't want to be like that. So chime in whenever you feel like it.
Okay, so modules, because as soon as you do complex C++ systems, you hit your head against this problem of what is the public interface I should be pulling in, and how does it physically has to be represented, and the, let's say, historical way of having headers and so on. It works because it worked before, but it has clear limitations. And modules take this and put it, in a completely different, mode of operations that bring a lot of benefits. And then concepts. I really wish we had concepts before, but there was a lot of issues with the first initial proposal. And now the so-called concept light proposal by Andrew Sutton and all the other guys, I think they have a decent chance to get in, even if they have a lot of issues still. But it looks like something you can actually work with, and it's there is this word which it's grokkable. You can understand in some kind of intuitive way what you should be doing, which was clearly not the case with the previous proposal. And the fact that you can actually describe your type constraint in a way that it makes sense in the code and for the compilers, and it doesn't have to deal with those pages and pages of errors because you forgot that, for example, I don't know, you cannot sort complex, stuff like this. Yeah. Just pulling out this one. It's cool. And it also opened up something which is, I think, is far more reaching, which is by actually giving tools to people to reason about what their template types are supposed to do in terms of contracts, concepts, what they should be modeling. It also helps people to actually structure the code in a better way, which is always cool, and probably, you look at your code, you conceptify it somehow, and then you click about, oh yeah, but that's concept if I, split it this way. That's basically this one plus something. So I can probably, reap all the benefit of the other ones, and my code become more generic. And by the only fact that you can actually express that, you get better design by, iterating over all of this. And that's something we really need, because I think that, template programming, not even going into template meter programming, it's a bit of a ghetto, in C++. You have the guys that do it and the other one. And you have the guys that do it because, obviously I cannot do it in any other way, so I will have to do it with templates. And I think it could be cool if we can actually bring back templates to, let's say, a first-class citizens tool for people. And I think concept actually push into the correct directions.
Okay, cool.
Concepts. I want to say something about concepts.
Please go on.
So there was this absolutely, I think, awesome story how concept light became light. So Bjarne and others actually worked with concept. It was voted in C++ 11, but it was huge. It had unbelievable number of concepts, like
100
50
something, I believe.
Right,
Yeah.
right. So eventually Bjarne himself killed it. He says like, no, let's strip him out. Then sometime later they flew to Palo Alto, where Alex Stepanov is, and they brainstormed like for some time, and they came up with 12 or 13, some very small number. And I wanted to see them, right? I found that paper that published that, and I flipped through all of the pages. I cannot find the list of concepts. And eventually, like on page 3, there is a tiny little, one, maybe eighth of a page, little chart with a few words. That's all. So it was incredible feat of Alex Stepanov and others that helped to give birth to concept light. So that's my anecdote about concepts. You said concepts. Right? Concepts. Here we go.
So I definitely want concepts. I like the computer screaming at me, especially the compiler screaming at me, especially if it's succinct and,
we
and
pay
accurate.
for that anyway.
Yeah. Keeps me from checking in bad code. So I want that. I want await, very much so. I love the way that it rewrites your code so that you can not really pay attention to the fact that you're doing these swaps back and forth between different contexts. But I'm also in the library space really looking forward to having an actual asynchronous source built into the standard library, ASIO. I think that would be spectacular to have, and executors having some real abstractions for introducing asynchrony into your code. I think it's a good start. In general, I think that the tools that we have in the language right now for asynchrony are kind of like assembly code. We probably shouldn't use them.
Why is that?
They're too low level. The reason why you end up with deadlocks and race conditions and all of that is because you're dealing with concepts that are just too low level to express the ideas that you're trying to write code for.
Yep.
So I'm much more interested in the one that I've been investing in is reactive extensions for providing a surface under which you use threads and mutexes, but which no user ever has to see.
Okay. So, let's talk more about concepts, because you have mentioned concept slide. And I remember when they were discussing concept slide, there were talks about the fact that we are going to need new STL for that. Because the reason the first concepts proposal was so big was because for every algorithm you eventually ended up repeating all the syntactic constructs that were inside, because otherwise you would break user code. So do you know anything about that? Are we up for STL2 in C++ 17? Or how are these concept slide going to interoperate with existing STL? I mean, will we have concepts in STL, or what is it going to be?
Yes, there will be STL v2 that will be conceptified, and it will be done with ranges too. So there will be a lot of changes that will clean up the STL, but it will be in a different namespace so that it will not break existing code. I think some people are of the opinion that we should not put the concept in until standard library is conceptified.
Yep.
But if you think about it, would Alexandr Stepanov have done STL if there was no templates at all in the C++?
Very unlikely.
So pretty much, I think language features should come first. They might have mistakes in them, but it's real people, actually not just one person or two. It's the millions and I guess millions, right?
It
of
is,
developers
I believe. It is.
In the world trying crazy things, and then some of them will come up with awesome ways of doing so. I say we should not wait for the STL to be conceptified before we get concepts in the language. And I'm on that side of the argument.
Okay.
Which makes sense actually, because I mean it looks like a chicken and egg problem, but actually it's not. I mean, you just put whatever, and as you say, you let people play with it, and so use cases and idioms came out, and we know what you should be doing. I mean, that's basically what brings us, polymorphic lambdas. If we had back in the day waiting for lambda syntax perfectly perfect, we probably doesn't have them right now. And by having this, okay, let's ship this, let's see what people do with it, what they complain for, and so we can have another pass on it. I think that's the correct way to handle those kind of evolutions. And I think, I think we need concept in the wild with whatever defects, let's say, they may have, because you cannot future-proof everything. And see what people do with it. And maybe we will find out that people doesn't care about this part, and they really, really want this, and then we can actually, shape the evolutions. But I'm probably against waiting for everything to be right to put concept in. We will get stuff wrong. It happens. It's not like we have perfect knowledge of everything. So we need actual people writing actual code with the new features and see what sticks.
Yeah, well, makes sense. Yeah.
So Eric Niebler's work on the Sentinel iterators and the range v3 proposal was one of those things that's going to really help the concepts match the new STL by allowing the two iterators to be different types.
Okay, so just to remind you guys, so that this is actually a big Q&A session. I'm going to, to stop right here in the tracks and answer some questions from our online users who are watching us right now. And I want to remind you that you can interrupt us in the tracks just by raising your hand, and you can scream like, oh, I have a question here, and we will listen to you. So do not hesitate. If you are having troubles with English, you can say it in Russian, and then I will translate, okay? So we have a question from one of the guys who's watching us online, and it is about C++ core guidelines. I believe you have heard about them. I believe Bjarni is involved, right?
A lot of people are involved.
A lot of people are involved. So how do you think? What are the perspectives of this effort? Where could it lead to?
I think one of the main, advantage, let's say, or things it can bring is that it's the FAQ to end or the FAQ, let's say it this way. There is a lot of people having misconception about the language, and actually having a group of, let's say, experts, practitioners, because you can actually contribute to the core guidelines. Everything is on GitHub. You can actually, ask questions about unclear parts. You can submit patches and so on. And I really, do it. If you're interested in doing this, and it could actually bring back, back the language in a place where you could actually use it without, eating what I call those, those ugly urban legends about the language. It clears up everything, And if you look at all the guidelines he's made, it looks like a bit like this. It has this part about, okay, I want to deal with exception. What should I do? And it goes through, okay, you need to do this, you need to do that. This is false, this is true. And I think it's a very cool way to get people back. And it's also what I will put my teaching at for a while. It's also a great teaching tool. And I think it could help, bringing a new generation of developers to C++ with a proper, background on how to handle those kind of issues.
Yep.
Yeah, I'm very interested in the tooling that's going to be associated with it so that you can actually run your code through a switch on the compiler that will report when you're not following the guidelines. And I think, again, I like it when the compiler screams at me and doesn't let me check in bad code. So I love the idea that these aren't just another book with a list of things that you should do, but you're actually going to get tools that will help you make sure that your code does them if that's your goal. Like if that's what you want, you can enforce it.
This is great. This is great.
Just one more thing is that in '98, Björn Strostrup published an article called Learning C++ as the New Language. And he was saying that people really don't understand how to use C++. They use it as C, with maybe malloc, now called new, and free called delete, and
They still do.
And they still do. And C++ has both, it's a good and a bad thing for C++, is that it has C as a part of it. The fact that it has C as a part of it means that we can interrupt very nicely. The transition path is very easy, but it also means you can revert very quickly back to C, and then you lose the benefits of C++. And GSL is an attempt to try to codify that C++ part. And combined with the tool of automatic verification, suddenly you don't have to have some important Bjarne looking over your shoulder saying, no, that's not C++, you're going back to C. And now the tool can just nudge you on the shoulder and say, hey, use that. So yeah, it's just to chime in
Okay.
And you have to understand that you have the Gor guidelines and you have the core guidelines library, which is the actual, implementation of what you should be doing, so you don't have to do it yourselves. And it's an invariable tool. So if you really want, to go into this core guideline stuff, use the library which goes with it, and it really opens a lot of, new way of thinking about the languages. It's really a bundle.
Yep. Well, this is cool. Okay, and we have a question from Moscow actually, and several more here. I'm going to serve you in a first come, first served basis. I hope I won't forget anybody. So, Moscow, please go on.
Okay, thank you. We have a question here in the fourth row.
Hello, I'm Sergey Ivanov from Network Optics. The Gor said that one of the bad things in C++ is high compilation time. And a lot of languages now have good support in IDEs because they can show great hints, intelligence, because they compile just in runtime. When the developer prints something, the compiler pops out, hey, you're doing it wrong. And in C++ it's impossible because compile takes a lot of time. What do you think? Will the modulus be that silver bullet that will allow compiler to increase its speed dramatically and helps developing just in runtime, just as we print?
Yes, I think it will be dramatic increase for edit, debug, test cycle in your IDE, because when you're doing batch compiling for release, probably you have link time code generation, and essentially you are compiling your program at the link time on its entire thing, and you run the optimization algorithms. And modules will not help much with that. But if you are in your IDE and the rest of the world are in the form of modules, and you only have to compile, 1,000 lines, that's instant. So I really a believer that we will get to a model where your editor will compile your program. So it will be already compiled by the time you finish typing your last character. Again, I'm a dreamer.
Okay, thank you, Moscow.
We actually have one more question. So shall we ask it now or later?
Since we have it there, please go on.
Okay, thank you. So please.
Hello, everybody. My name is Alexey. I'm a software engineer at Avi Software House. So I have a question about maybe later future than C++ 17. So basically, Gor mentioned that people, when coming from C to C++, that it for them like C#, yeah? So basically, I think that it's not true because I develop on both of these languages. And so the main problem that when I develop in C#, I think less. I'm more writing and less thinking, yeah? So because I think that the main problem is memory. So when I write new in C++, I must stop and think, who will delete this object? Who will own it, yeah? Who will call delete? It's a really big problem. So, and if we pass it to several dynamic created objects to the functions, then we must keep in mind how we create them, and if we have exceptions, that they all will be correctly destroyed. Of course, it's a lot of problems that we have deal with. And my question is, do you plan in maybe later future to deal with it? Maybe if you know Objective-C, maybe you want to add something like after release pool with that already used in Objective-C, or maybe something else. Of course, it's not all situation it will not be suitable for all situations, but maybe in some situations when we just need to write code and not think about memory, maybe it will be suitable. Thank you.
Who is up?
Well, I think the tools you need are basically unique PTR and shared PTR. C++ has these, resource allocation systems that you can actually have cleanly destroyed and cleanly, reasonably, you can reason about what your object's life cycle is. And basically, I think that there was a presentation, I don't think it's Bjarni or someone, which is called, basically, you know this very old paper by Dishra about Goto considered harmful, and someone write one which is basically new delete considered harmful, and basically you have to move from this manual handling of resources to a more automated systems using whatever the language is giving you. So C++11 introduced a couple of smart pointers, let's say, call that like this, which are more like life cycle aware pointer, like I like to call them, and it turns the problem of who deals with what and when from a runtime issue to a compile time issue, because you cannot do what you want with a unique PTR, you cannot do what you want with a shared PTR, and it forces you at the compile time, at the design time even, to think about what the life cycle of your object should be. And using those tools and all other era2i enabled types like vectors and also stuff like this, you basically that probably 5 years I didn't write a new in a piece of code, and well, I'm still living a good life. So we already have those tools. I think we had, is it optional? I think we have also an optional garbage collected version of the C++ runtime in C++11, but I doesn't know how many vendors actually ship one.
They added wording that would allow adding a garbage collector, but
nobody did it.
No. There is one quote, awesome one. I don't remember the guy who's C# developer, and or not just C#, but he developed in there. And his quote was that, let's see, free. Okay, one more time. Wait. I'll remember it. Yeah, free memory is like free puppy, or it's about garbage collection. And free puppy means you get it for free, and then it leaves the mess all over the place. Because it's only initially that, again, I only speak from my experience and a few people around who know, so I am not saying it's the way it is. But it's only in the very initial phase of your product. You don't have to think about resources, whether using the managed language or C++. Because after you finished the initial part, you will discover that you still need to care. I observed people who were doing work in managed languages. They had to resort to do their own ref counting because they had to guarantee certain things to go away. And guys, in C++, we're getting that for free. And I'm not sure what is the proper Russian term for RAI, resource allocation, is initialization.
We don't have one, I think.
But guys, this is the essence. This is like the best thing in C++, because it means if you want to use something, you must declare it. If you declared it, it will be properly disposed of. So it's magic. So use it. And yes, some people say, yep, what about cycles? Well, it means you have to think about lifetime, because maybe some of those relationships are not ownership relationship. Sometimes having a back pointer back to the parent, normal one, is absolutely fine.
Or use the core guidelines owned of T which is actually just that, but with a nice typing.
Yes, so maybe there are projects where it's perfectly fine not to think about memory, but at least in the ones I encountered, eventually you would have to think about it. And
okay, so there was a question here, like what about this thing in multi-threading context? It just works, I believe.
Shared pointers as an atomic counter, so that's not
Yeah,
an
they
issue.
just work.
It depends. So I think when you try to mix ownership and multi-threading, you have to look at examples how it is done in the operating systems. For example, I know about NT. They have two reference counters. One tracks ownership of the object by the user. So for example, if you have a file object or some other object in the user space, when you let it go, it means you don't care about it, right? You want it to go away. That's one ref counter. There is a second ref counter that user does not directly touch, which deals with all of the synchronous activity related to that thing. And until that second ref counter drops down to 0, you cannot remove the memory. So we don't have yet this model in C++, but I believe when you think about how to do the ownership, you have to split up the ownership relationship where I mean to use it, and then when I stop using it, I don't care, please go away. And then, look, all of this stuff is in flight right now, and it all has a handle to my memory, and is going to write into it whether I want it or not. So you have to have a second one as well. We don't have facilities yet for that. I hope we will develop them, and then it will become not a problem. Because, as I mentioned in the beginning, after we cleaned up normal errors, normal bugs because of the C++ RAI, the leftover bugs were all in asynchrony. So this is not yet solved problem in a nice way, but I hope it will be.
So on the original question, I actually know that I could speak at great length, but I will try to just add a couple of things to what's already been said, which was some of what I would have said anyway. I did actually observe a team in Windows doing a very large managed code project, WPF in fact. And I watched them rewrite it 3 times. I watched them redesign the dispose pattern at least 3 times, and everyone had to go rewrite their disposes across all of their objects to match the new pattern until they got it right. I saw the safe handle stuff where they had to actually manually dispose of resources in order to get rid of them. The idea that you can write without thinking about lifetime is probably not going to work in every case. On the other hand, I've had long discussions with friends about how nice it would be if you could just say, I'm going to do this scoped operation, here's a heap. When this scoped operation is done, free everything on the heap for me. I don't want to individually track any of this information at all. I know my scope, and I don't need to individually track any of these things. And having that kind of level of garbage collection might actually be a great addition at a library level for C++.
Oh, well, thank you. So we had some questions from around here, and who was the first one? Yeah, please.
Okay, thank you for being here today, like all of you. Speaking about
speak please closer. Yep.
Oh yeah, like this. Okay, speaking about the distance learning, there are quite a few platforms out there now. So, which one do you find the most engaging for C++ newcomers and for seasoned professionals? Like, which ones do you find the best ones?
Which platforms are you?
Yeah, like the distant learning, like Treehouse, like Hexlet, like things like this one.
Good question. I don't have any more opinion than that.
I don't have any experience with
Yeah.
them.
So who has experience, huh?
I don't have an experience, but there is a YouTube, and you can, listen to Alexandr Stepanov's lectures, Bjarne's lectures, and, some percentage of that maybe we'll actually be learning. Because depending on your level in C++, there is a good chance that you know 90% of the stuff they're talking, but then there is the 10% which is new to you. And and you have to watch a lot to get to that 10%. I don't know of any easy way to get there.
Well, I think that for a newcomer, like say you're just beginning, I think the most challenging task is that it's filtering what's available to get to the to get the correct starting point, because you can actually fall on something and you basically get dazed by the complexity of the languages, or on another part of the spectrum, which happen a lot, you end up on C++ courses, which is more of a C++ courses, if you see what I mean, and those are rather detrimental. It goes back a bit to this core guideline stuff. I think that some kind of teaching material out of the core guidelines could be something that could bring something out of that. But I think we also need being a beginner in a language, whatever it is, it's a very it's a very specific position, and I think we probably need actual material for real beginners. I don't think there is that much.
Tour of C++, which is very short, recent, Bjarne's book. Essentially, he wants to explain that C++ is not a complicated language if it is taught right. If you don't focus on template metaprogramming and a lot of other things, if you just show, look, this is how you use it in the right way. It's a very thin book, and it can be taught C++ to newcomers in just like in 3 hours or 4 hours. You can read the book.
Yeah, it's a great book. I also think that Kate Gregory has a bunch of teaching materials on YouTube, and I think it's under the Microsoft Teaching Center, or I don't remember how it's called. And it's a very down-to-earth beginner materials. And Kate is a very great teacher, so hi Kate. And you could probably start from there, and the material is actually of very good quality. But yes, it's actually. I think the difficulty is filtering the amount of stuff.
Okay, in this case, I have one more question, like quick one, like
quick
small
one.
a tiny one.
Please go on.
Okay, so
Holy closer.
Okay, so basically, do you see something coming to replace Qt, like Qt, in terms of embedded Linux development, like multimedia stuff or IPTV kind of stuff, and like all kind of multimedia use cases? Do you see something coming to replace Qt in this one?
In the standard, you mean?
There is a group dedicated to input-output in terms of potentially graphics, but it has very low paper churn, and unless people contribute, it will stay that way.
So Qt would stay the same kind of.
There was some talk about standardizing a C++ified version of some GUI library. I don't remember the name right now. Was it Cairo or something? Yeah.
Yeah.
But that's pretty much all. But I think Gor is right about the fact that we need people pushing alternatives.
Because like committee doesn't design anything. It's just some people who care a lot about something that driving it forward. If something is very important to you, try pushing it.
And that's probably a question that will come up afterwards. But standard proposal, it's open to all. You can read a lot of them on the internet. There is a Google groups called STD Proposal, where you can actually discuss stuff. You can actually push your ideas, and if someone think it has merits, it could actually be picked up and be working on. So don't hesitate to go on there, read what people say about subject that may interest you, and push new subject on it. As Gor says, we're not a chamber of recording, but we need input from actual practitioners. So the standard makes sense.
Yeah, and I'm not an expert, but I want to chime in on this one. One of my friends have written a proposal and went to the meeting. Well, he is going to the meeting that is going to take place this Monday or something. So it is actually pretty easy. You just write up your own proposal. Do that. So thank you, and we have a question from Nizhny
one tiny
Novgorod.
little thing.
One little thing. Please go on.
Very, very little thing. So, not only writing a proposal can force other people to do work. Oleg Smolsky did some proposal about default comparison for C++. That paper prompted Bjarne to do his own. So it's not just that maybe your proposal will come, but your proposal can trigger somebody else to do the competing proposal that will go in. And so essentially, Oleg forced Bjarne to do work. That's wonderful.
Which is quite cool, yeah.
Okay, you know.
Okay, so Nizhny, please go on.
Hi all, my name is Oleg, and I have a question about heap fragmentation in memory allocation in C++. If you have a small amount of memory, and if you frequently call new delete operations, your heap fragmented. Is there any internal tools to help developer with
You can speak in Russian, and I will help you out. Можно говорить по-русски, я помогу.
to investigate this problem, and for example, any simple memory managers or other tools.
Okay. So who can answer that?
I don't think we have anything in the standard. There was, that's clearly the work for something else. I think we have something in Boost, which is called Boost Memory Pool, that can give you strategies to do that in a certain way. I'm not sure what the statute is, because it's an old library. I'm not sure about the quality or performances, but it does a merit to exist. Depending on the use case, that could also be a job for a custom allocator, maybe using an arena or something. I don't think we have anything, ready on any plate doing this.
I think the question was about tools to monitor fragmentation.
Oh, monitoring. Oh, yeah.
Yeah. So no, I don't know.
Don't think so.
But there is TLS alloc. Have you tried one or TLOC?
TLS alloc.
Yeah,
Tmalloc, no?
Tmalloc, right. Maybe that one will help. No, it's just a good alloc for some patterns.
Also, may I ask another question? This question will be about Unicode supporting in new C++. For example, can I use enums with Russian string constants?
So Russian in my C++.
First rule of C++ Unicode is you don't speak about C++ Unicode.
Okay.
I'm joking. No, I think we have support for.
So are you talking about the identifier names or
Identifier names? Yeah.
look, I don't know the standard very well. Do they ban Russian letters? I thought that encoding.
I think source code can be UTF-8, no?
Yeah, I think the source code can be like. What is the compiler you're using? Like, fix your compiler.
GCC.
Did you try it on an MSVC?
Oh.
No. Or Clang. So.
Product placement.
Okay. Thank you for your questions. So we have some more here, I guess. Yep. Okay, Natalia is in charge, so she can pick the cutest one, I guess.
Okay, I want to back with Will to the new features in C++. So
and please hold it closer.
Okay, so the first question is about concept. Can you shortly compare it to the interfaces in Java or try it? And why you replace it? Why you cannot do the same thing with the abstract classes, for example?
And one by one. Please
Okay.
go on.
Okay. So the question was, is it? No, it's not like Java interface. It's more like, I will try to do my best Bartosz Milewski impersonation, it's more like type classes in Haskell, I think. So this means that you are specifying what your type interface should be in terms of syntax. So what is the syntax part that you are allowed to do with expressions involving values of these types, modeling this concept? It's meant to be checked at compile time, which means that you actually have a compile time check that you are actually using your type the correct way with respect to the syntactic constraints. While when you work with abstract classes and stuff, you build a runtime contract. Okay, this type at runtime. Okay, this way. Oh, okay. It's basically a runtime contract, so that you have to be, your instance of your type must satisfy the interface. So it looks the same, but it's a different time into the compilation. So concept is really about, this is the compile time valid expression I can write with my types. And this goes further than abstract interface because you're not tied to an actual classes. You can actually have concept defining the fact that your types as an operator or something. So I would say it's more powerful somehow. I mean, it's different. It's a different problem it solves, but you get more flexibility in what kind of constraints you can explain.
Please speak in the microphone.
So it's look like a compile time duck typing, right? If it has...
If it quacks like a duck, then it's a duck.
I think the current situation is duck typing, where we're saying, look, it's T, and then go try to figure out. Now we're saying that, look, it's supposed to be an iterator. And by the way, concept mechanism, check those things. But to the developers, we'll say, dude, you're supposed to give me an iterator, and as opposed to, hey, this failed because of, I don't know, this didn't match. So that's like one benefit of concept. There's also hidden benefit of concepts is that you can notice that requires can be applied to just plain functions. What it means, you don't have to have pound if defs, say based on platform, because now you can say this function requires and this constant expression, the platform equal AMD64, and this function requires something else expression. So it actually amazingly good. It can do even more than concepts.
Well, this is cool. Thank you. And we have a pending question. Oh, you wanted to say something? Did I break you in mid-sentence? No? Okay, sorry. So we have a question from Moscow. And Moscow, you there? Moscow, hello?
1-1, can you hear me?
Yep.
Yes, perfect. So we actually have plenty of questions, roughly 5 questions as far as I can recall. So please your hands, we're still eager to ask one. Okay, so this guy in the gray shirt was the first one.
Hello, my name is Michael.
Please press the red buttons.
Hello, okay. My name is Michael, and I would like to ask a question about standard committee. There was a talk about evolutionary group, which has crazy ideas. And I would like to ask what was the most crazy idea that was rejected, and what was the most crazy idea that was accepted? Thank you.
Oh, we had this, what was it called? There was a proposal about having a way to, I think that, let's say, the most craziest idea that may go in my opinion, is this proposal about overloading operator dot. So you have operator dot, like you do my object dot something, and what about changing the meaning? So it looks very strange, and why do you even want to do this until you stumble upon the problem of proxy types, which basically are, I'm looking like a value, but I'm not. The most obvious example is probably reference from a vector of bool, for example, where you have to go through I don't know how many hoops to get it working right with all the rest of the languages. While you could actually do something that say, okay, I give you something, and whenever you do dot whatever, I'm getting whatever I'm referencing and calling dot whatever on that. And it opened a lot of nice design for a lot of issues. And it actually did the same thing that happens with the default comparison operators. Bjarne stood up and or was it Bjarne or someone else? But
so yeah.
There was a bunch of guys. Okay, yeah, we need that, but I really want it to be this way or this way or this way.
Yeah, but the end result was brilliant, right? Initially, it started with, hey, let's add a way to inject comparison operators, and then Bjarne came and said, hey, how about we just automatically generate them for everything? And then he told a story that it is by pure accident. And by the way, people in the committee were like, oh my God, this is unbelievable. This is impossible. And then he explained that it is by pure chance that it didn't get default comparison in C. So the issue was, since in C structs, they are copied, right? We can actually assign them. So we do copy. And he checked with Richie whether he was thinking of doing equality and comparisons. And yes. And the only reason why it didn't make to C because of padding. C didn't have, member-wise and generation stuff for members, so they couldn't exclude padding. That's why C doesn't have them. But C++ easily could have gotten them in the beginning. So essentially, it was interesting to observe that there was something that obviously could have been there in the beginning and nobody would have asked, but it was a lot of, concerns and excitement about it.
Okay, so the thing is, we have questions coming at us from all directions. So, I'm going to just pick one from each one and we'll proceed like this. So we have a question from the guys who are watching us online. And the question is, are there any plans to support vectorization at the language level?
Okay, so there is a lot of thoughts going on that. There was a bunch of proposals that were sent up to SG1 because we thought that, vectorization and parallelism and concurrency, that kind of it. There was a lot of discussion about, is it actually something we need explicitly in some kind of, types-based systems, like we have STD atomic, do we need STD, SIMD vector, or whatever? And a proposal we actually wrote was actually based on the fact that people in SG1 was actually familiar with that, which was an error. So we got rejected, and Matthias Kretz, which is working at CERN, actually came up with a very similar yet different proposal, but it got the idea right of actually explaining what vectorization is and why it's important. So it's basically there, but we moved from SG1 to SG14, which is a low latency and games study group, where actually people were clamoring for having something. So we had an audience there. So there was a series of telecon like the last month about that. Progress are made. We are still not sure how to do it because we still have a lot of people in other parts of the committees that still think it's only a compiler issue. That means that if your compiler auto-vectorizes, it's cool. If it does not, it's just a QoI issue. Except you have a lot of contexts where it's not a QoI. I mean, if you don't vectorize, you just have 0% of your performances. It's true for a lot of embedded systems. It's also true for a lot of new, high-performance accelerators, mostly Intel scanner and stuff like this. So either we wait, like we did for probably now 25 years, that compilers auto-vectorize whatever all the time with no errors, with every capturing every pattern possible, which is I personally think is not something that's going to happen. Auto-vectorizers are very good, and they do a lot of, let's say, black voodoo magic in some cases, especially ICC, which is vectorizing stuff in a great way. But you can still find patterns that when you are a human, it's vectorizable. And if you did a bit of SIMD programming, outwrite it with a proper, patterns. But there is no way the compiler can actually understand that. One of the most glaring example is you have a lot of code that doesn't look like it can be vectorized, except when you learn about shuffling, which is an operation where you can actually move elements inside the vector, and you turn this very complex memory access into something that says, oh yeah, just load this bunch of memory and then, shake everything and done. It's vectorizable. And that's something which is very complex because that means that the compiler has to have a model of what's happening to the memory. Is it something I can shuffle and so on? So I think there is a place for, let's say, explicit type-based vectorization. Next to that, there is a lot of work that has been done on the STL executor proposal, where you could actually write something like, I never remember the order, but it's basically std transform, my first iterator, my second iterator, my output iterator, my function, and I want this transform to be run this way. And this way can be like normally using cores, using GPUs, and using vectorization. So that's still very, the interface is basically there. Now the issue is how could you go from there to an actually vectorized or multi-core version of the algorithm. That's another issue, especially when you could actually pass an arbitrary function to the transform algorithms. But let's say that basic, so the basic stuff you want to do with vectorization is I have this whole bunch of, of data and I just want to go over, especially supposed to be supported by this proposal. I think it's going to be in a technical specification, I guess. I don't remember.
Parallel TS, they are proposing to move it to the standard. Not sure how it will.
Yeah,
because all of the algorithms with extra parameters,
extra stuff, yeah,
they are in parallel TS, and there is a motion to put it into the standard.
Okay, but it was supposed to be into a TS, probably.
I think it's already in the TS.
Is it?
Well, you're talking about the algorithms with the extra parameter, right?
Yeah.
So yes, it's in the parallelism TS.
And so, yes, it's a very complex problem. I think we will be getting out of not the statu quo, because it evolved, but it evolved a lot when we switched to SG14, where you basically have a lot of people that deals with, okay, I need to vectorize this on this frigging embedded system, if not I will die, coming out of the, of the bush and, expressing interest. So there is work being done. Don't think it will be for 17 right now. It's far too late, but maybe the next iteration. But there is people involved, interested by that. If you really want to see where it's ended up, go and look at what's going on the SG14's study group, read the paper, see what's going on. But there is definitely activity on that, and I hope we can actually have something done, probably for the next standard or the next one. But there is work being done. Yeah.
Okay. Hear me? Okay. Yeah. Thank you. So the next question is actually related to this one, because one of the ways, and I believe Joe, you will be answering this one too. So be prepared. So I believe one of the ways you can do vectorization is by using domain-specific embedded languages for it. So the question then is, what do you think about using domain-specific embedded languages extensively in C++, and what do you think about domain-specific languages without embedded in the middle? It's like languages that you create for a problem that you then generate C++ from. Are they used in the wild? What has been your experience?
Okay, so maybe we should, so domain-specific embedded language is a way to take an arbitrary, often declarative languages, which is a very simplified language that solves one family of problem, and only this one, but correctly. And by being declaratives, you could actually reap a lot of benefit, because you could actually ask, you describe the problem to the compiler using the language or the library, and the compiler/interpreter can actually look at your problem description, and he knows what he has to do, because you're working with a very strict set of entities and relationship between these entities. So one way to do this vectorization, has been to write, embedded domain-specific languages where the notion of SIMD register is actually the entities, and operation on them can actually be, parsed beforehand, and you can actually replace patterns with more optimized patterns by calling, for example, a fused operation or removing constant that doesn't need to be there. Embedded domain-specific language or domain-specific embedded language, depending on where you come from, it's a love-hate relationship in C++. It solves a huge stack of problems. There is, I don't know how many libraries dealing with this kind of techniques to solve different kind of issues. And they usually solve it very well. The problem is, the tool we use in the language to actually build those kind of library parodying as a languages is probably the most obscure ones. And when something blows up because, you make a mistake or whatever, I mean, it's not, the joke about, C, when you do an error, you can shoot your foot with a gun. And when you do it with C++, you basically hack it off with a chainsaw or whatever. And when you have an error into an embedded domain-specific language implementation in C++, that's basically a nuke, the poor user is exposed to a high level of, details he doesn't even care about. And one of the solutions was to try to make those kind of techniques more like, there is a lot of language, which is not C++, where you can actually design embedded domain-specific language just by just saying so, which is not the case in C++ because, that's a technique that appeared afterwards. And it's tied to the way template metaprogramming is actually used into the language, and not just used, but how you can implement stuff. And template metaprogramming is clearly, I think we can clearly say it's an afterthought in the language. It just happens to be there by accident, and it opened a lot of doors. But the language is not meant to be abused this way, and it clearly shows. So one thing which was cool with C++ 11 and 14 is that we have a lot of stuff we were doing by hands that just ended up into the standards, like const expr, threads, and stuff like this, or even a simple thing like integral constant. And it simplified a lot of things, but there's still a lot to do. So yeah, it's one way to do it, but you can do it without it. It's just, sometimes, it just, helps to what's the name for, we have a word in French for that. It's just, sugarifies the interface so it looks like, more appealing to the end users. But you can do without it. And for the other question about DSLs, which is basically the same thing, but as an actual languages with an actual other set of tools, that's something which is actually gaining traction for a lot of time. And was the funny thing is that people rediscovered that a lot of time in different languages, in different domain. You have a lot of people that actually do domain-specific languages without even knowing it, and that's something that works. There is, every time you see someone writing a new ML diagrams and using Eclipse to generate a basic Java implementation that, when run, would generate some whatever C or C# or C++, that's basically a DSLs. Yeah. And there is a lot of domains where this is gaining traction because not just for the whatever advantage on the runtime, but the fact that you can actually take people which are experts in something and they can just use the language or the library directly because it just looks like what they write on their blackboard. And they doesn't have to, let's say, learn a new language or whatever, and the tool is doing this. And this is actually a way where a lot of tooling is going. There is a lot of efforts going on there. So I think that, so DSLs is definitely a solution to a bunch of problems. Their embedded versions, and especially in C++, I would say it's a necessary devil because it solves a lot of issues that the language can't handle right now. The fact that you cannot just have a bunch of, you can't access the representation of a bunch of arbitrary programs that a lot of language let you do. But I hope it's a transition to something more, integrated. But that's a lot of work. It touches a lot of, core elements of the languages. So it's not gonna, appear like this way. One strategy we had with a bunch of other guys is trying to isolate small problem in the implementation of DSL and solve those by providing solutions that solve these issues and happens to actually solve a more general, class of problems. So it doesn't fit like, it doesn't feel like, oh yeah, we have these very corner case-ish things. I really want it to be, supported. Please. But you can actually find more general stuff where you can actually solve this problem. So I think it's going to stay for a while. And yes, that's one solution to these issues.
Okay.
Hopefully brief comment that, in my opinion, the range library that's going in, I hope, I can't see any reason why it wouldn't. Yeah, is in a sense pretty much a DSL for connecting algorithms together to process, sequences. And I think that I much prefer that type of library-based DSL than the compile to, because I deal in my current job with a lot of these compile to type things, and none of them have source debugging, none of them have breakpoints. Like if you're going to build a language, there's more to it than just, a parser and a generator into another language. And it really bothers me that, when you don't have the whole a whole language environment for your DSL. So I like the more, range v3, and actually RxCPP does the same thing, where it's a library. It's still C++. You can step through it. You can figure out what's going on.
Okay, thank you. So yeah, I see like a lot of hands here, but one of the guys in Moscow has been waiting for really long. So Moscow, please go on. Moscow.
Okay, thank you very much. So the guy in the red skirt, yes, you please.
Oh, see, red skirt brings you.
Oh, you wanted to ask a question, no? Okay, we have two questions in the back row, please. Yeah.
My name is Dennis. I have a question. I think that modules is a good step to removing some parts of preprocessing, because we all know that preprocessing generates huge files, and that makes compilation I/O bound, and also gives a lot more job to compiler itself and to linkers also. It generates some condet sections and all that stuff because of that. So the question is, if we go further to remove other iterations of preprocessing, because there are lots of them, like string concatenation, tree graph removing, and macros even, that's all from previous century. Will we go forward to remove preprocessing completely? Thank you.
Okay, thank you for your question.
Yes, there are people who really want to completely get rid of preprocessor, but there is a fight in Jacksonville that there is a part of the group who wants to put preprocessor in the modules, because current proposal is adamant that we will not export a macro. If you import a module, you will never, ever, ever, affect your preprocessor state. Another thing which will remove some of the need of preprocessor are actually concepts I already mentioned. Requires. Trigraphs were removed. They are gone. The IBM fought long and hard, and then they graciously allowed trigraphs to be removed.
Can I chime in on this?
And yes, but I haven't finished.
And the nice thing about preprocessor removal, like you never supported it in the first place, I believe, in Visual Studio.
Ooh. Okay, I will leave it without comment. I will still finish my thought. So about string concatenation, reflection study group is actually working on that. So I think out of all of the things you mentioned, we have either already proposals on the table or in the study groups that will help cover those cases. So yes, my hope that eventually you will not have to use preprocessor unless for interacting with legacy code.
I meant tree graphs. Okay, so we're done with that. Okay, another question from Moscow. Yep,
yeah,
Moscow,
thank you.
Please go.
So, please.
Hello, my name is Dennis. I actually have a strange question. We have a proposal to implement WebAssembly. It's JavaScript-like client language for browser. So it's C, C++ will be compiled to WebAssembly. It's some kind of binary blob, and then executed as JavaScript on browser side. What's your opinion about this? Can C++ rival JavaScript in browser and web world?
I think this is wonderful. M scripting and WebAssembly, it is wonderful. It allows full power of C++ and optimizers to run in the browser on a JavaScript. WebAssembly is a step beyond that. But guys, this is incredible. I love it.
Yeah, that sounds like a cool idea.
It's not an idea. It's there.
I know, but
Yeah, my slides are actually, I take the sample code, I compile it within Scriptin, and when you flip to the slide, the JavaScript compiled version of the C++ code runs in the slide, and the output prints out in the slide live. So I think that technology is pretty cool. I like being able to compile my C+ to run anywhere.
Okay, thank you for your question. So I guess we should, go here, please. Well, as always, the cutest one gets the microphone. Okay, just figure it out,
Thank you. If I understood Gor correctly, it's still not decided. Will be modules in C++ 17 or not? Yeah.
At the moment, modules are as a technical specification, and there are some people who want some changes, and that's why they're slowing modules down. And depending how it will resolve, there could be a motion if both sides agree to put it into the 17. Otherwise, well, they will stay in the TS, and some compilers will implement it, and some maybe not.
And as far as I know, MSVC already support.
Yes.
In some way, so they are support based on TC. Yes.
Yes, MSVC supports it, and it marks it as experimental because if anything in the standard changes, we will gladly break you. We will not promise to keep it as is right now.
Yeah, my question is what will be with the support of the modules if they won't get to C++ 17?
People really want modules. So they will be in MSVC. Hopefully they will be in Clang and GCC soon. Not the time frame. So essentially, I think modules is something that people wanted for a long time. And now we have finally a proposal which goes through core right now. So we are very close. We might miss 17, but it will be there for people to use, because one of the ideas why people push TSs so that there will be actual implementations out and people can try them so that they can decide whether they want this feature in the language proper. So yes, there will be TS. There is already implementation, and hopefully other compilers will also have it.
And is there some cooperation between people who do tools, compilers, and between people who are in committee? Do they cooperate?
I think all of the major compiler vendors are on the committee.
Oh, okay, thank you.
Yeah, thank you for your question. So another one then.
Hi. Will C++ parallel programming model be extended in new standard? Now it's two features, async and threads, and I think it's
not enough.
Yes.
So that's the point to speak about features, no?
So I absolutely agree with you. The current support for concurrency in C++ is not good. We might get some help in 17, or we might not. It's just that 17 is so close, and we might not get in. But there is, coroutines will have implementation in in MSVC, and there is a beginning of it in Clang. So, but it's just part of the answer for concurrency. So I agree with you. It's horrible right now. Hopefully it will be better in 17. I cannot give any guarantees.
Also, the fact we have a your studio group for that is actually, it shows that we actually care at some point. And I think we collectively know that we are probably, I mean, how to say that? We have been delayed into the proper support of modern parallelisms, but we try to, keep up with what is needed actually. There's a lot of proposals in SG1 that still haven't, seen the light of the day. So I think it can only get better, whatever the shape and the kind of support we get.
Oh yes, absolutely. Looking in the future, absolutely, it will get better. I just not sure about the next year.
Yeah.
Okay.
I'm as optimistic as Joel. It's just that not the short term.
Yeah, you had something to add.
Yeah, on the concurrency front, the thing that there isn't even, as far as I know, a proposal that matches what I'm about to say for 17, but I'm hoping after that something will happen, is we have tools now for dealing with...
Oh, can you hold it closer? Apparently guys can't hear you.
Sorry. We have tools now for dealing with individual values promise and future arriving in an asynchronous way. But I think the real power comes in when you have an expression for series of values coming in over time, and then the algorithm set that operates on those values, just like the STL operates on collections in space, having the corresponding set of algorithms that operate on values in time. And I think that is how we get away from the mutexes and threads and deadlocks and all that, by letting a few people write the STL or write the async STL, and then everyone else can just chain these algorithms together to get the behaviors that they actually want and not have to deal with the nitty-gritty underneath.
Cool. Thank you. Okay, sorry, but one by one, please, because we cannot really squeeze everybody in. So please go on.
Hello, my name is Nikolai. My question is, we speak about new features that will be added to the language, and from the birth of the language, newer and newer features added and will be added, and it's great. But the complexity of the language grows, and maybe the committee thinks about what is already obsolete. It's time to mark it as deprecated. And for example, when the modules system will be introduced, the role of preprocessor should decrease. Maybe there is an idea or some plan to move the influence of preprocessor from the language. Maybe there are some other dark sides of C++ that want to be marked as deprecated. What the committee thinks about that?
Thank you. Thank you.
I think we have a bunch of deprecated stuff in C++ 17. I don't remember the list, but it started to be,
Auto-putter was
What?
removed.
Auto-PTR.
Oh, auto-PTR.
Auto-PTR was removed. And then there is a whole bunch of little things which have been removed, like obsolete.
We are basically
mem
removing
fonts,
crumbs
on the library side. So there is some obsolescence, but it is very, very, very slow. And given that there is a significant fraction that wants macros in the modules, you can imagine what would be the outcry if we will try to remove the preprocessor. But if you don't like it, don't use it, and tell your friends.
Sorry, I will speak loudly. One of the trouble with macros in current state that the process of parsing it, especially in runtime when developer prints, is very high CPU. It's very costly. That's why the intelligence of C++ is slower and most silly than the same subsystems for Java, for C# and so on.
Okay, so I'm going to repeat this question just so that other guys get what's going on. So the question was, the C++ preprocessor induces really large costs on IDEs because in the IDE you have to parse like everything that this preprocessor does, and this makes IntelliSense slow and everything slow.
Well, we on purpose did not include any export of macros from the modules or any injection, of macros from the outside of the environment, because the idea was that in the wonderful world, there will be just modules, and there will be no, those annoying macros, and IntelliSense will be blazingly fast. But it is very likely that preprocessor will stay forever for some people who really, really, really want it. But it means that if we have a modules, we have other features which enable you not to use, and your teams and your companies, preprocessor ever, then it's as good as gone.
There is
okay.
just a few. There is also the on other kind of features, more language related. There is also this effect of cumulative improvement. I'm not sure what the status of the unified function definition stuff.
Unified function call.
Yeah, the fact that you could actually write stuff like auto f of auto x because you want to express that your function takes whatever types, but the type name itself is no use of you. So instead of having to write in template type name t blah blah blah, you can just use auto everywhere, like with lambdas.
Is this part of concepts?
I don't remember.
It might be.
It might be, probably, or
already.
Yeah. And this sounds like a new stuff to learn, but actually, once you have that, well, a lot of code gets simplified. And this kind of cumulatives, additions actually ends up by removing stuff you have to remember. And if you look at most of generic functions, there is a very few times you care about the type name. So you could already rewrite a lot of stuff this way, and you probably win a lot of, code amounts and stuff like this. So there is also this kind of stuff. There is also all the feedback we get from new features that can make better afterwards and simplified. So that's what happened with the lambdas between 11 and 14s, and so on and so on. So it may look like we keep adding stuff to the stew, but sometimes it just simplifies the old stuff.
Yeah, I think I want to second that. Is that C++ is horrible for the compiler, implementers, but the ideals and how it moves is that there is this current idea of what C++ is, and GSL or whatever is this guidance, GSL, I guess, they're trying to guide you toward this ideal language. And in ideal language, you would have only modules, no macros, but that's how we evolve the language. We have to preserve backward compat because that's the strengths of C++. But by using automated tools, you can push people toward the new good language, which is embedded in the old big language.
Thank you. So, we have a lot of questions from Moscow, so let's pick one. Moscow.
Yeah, thank you. So please, underneath the TV.
Hello.
Hi.
My name is Denis. I'm working at Yandex, and I have a question. I've tried to play it with PPL, with modern futures, and I've run into some trouble understanding how do I take care of my state. So, for example, I have a file that I want to read, and obviously I can only read it from it in only one thread at a time, or I can have like tops 5 TCP connections, and I don't want to use logs. I want to use just futures. How do I do that?
I don't think you do. I think this is one of the cases where you need to deal with streams of values, and you need algorithms to help you do that. So, you have in these types of systems, you have things combine latest that will let you combine multiple sources of change. And then you have scan, which will let you take each of those updates and emit a new state every time one of the updates has been delivered to the state, has been applied to the state by scan. And these types of algorithms, when you apply them, allow you to solve your problem just by chaining these algorithms together, rather than having to try and manually use the single valued futures to try and emulate this series of state changes.
And also PPL task and stood futures, they are not for the hot path. Like if you want to use your read API and in a loop returns a future PPL task, that is horribly inefficient. So that should be a better model. Hopefully it'll come.
Follow up, please. Where can I read something about it? I don't know. It's a good source.
The library that I'm most familiar with, the pattern I'm most familiar with is the reactive extensions, and there are implementations in a variety of languages. There's RX Java, RX JavaScript, and even RX Swift and RX C Sharp, and just tons of them. The one I work on is RX C++, and so you can look really at any of the documentation for any of them and start getting these concepts. There's lots of videos, and it doesn't, because it's the system that matters rather than the implementation, you can learn a lot just by watching any of the existing content.
Kirk, can I ask you a question? Does it handle cancellation?
Yes, it does.
Thank you. So one more question from Moscow.
Yeah, thank you. Please, in the back row, yes.
Hi again, it's Alexei. So I have one more question. So basically you have another pain in C++ when we deal with dynamic linkage. Yeah? So when we have several dynamic cloud libraries and we want to use them, and so assume that the IPs change, but we don't recompile our model, or if, for example, we add some new virtual function to interface. So we have a hard to debug undefined behavior, and it's a really big problem. So my question is, are you planning to introduce some mechanism to validate this call to different dynamic libraries and to make this call safe? Oh no.
So one benefit modules have is that you can embed the definition of the interface with the binary or object file. So you wouldn't run into a situation where you have a header, but something changed in that DLL. So maybe in that way it can help. But
we're still not going to have dynamic loading libraries in the C++ standard defined, right?
Oh, I missed it. No, not yet. Nobody proposed anything in that area. Actually, I don't think there is a lot about linkage in the C++. Like in linking, there is a linkage verb, but it's about...
Yeah, you speak about linkage, but there is no actual... we don't standardize what happens after the code gets compiled.
Okay, so another question from Moscow. You're going to run out of questions soon.
I hope so. Please.
Hello, that's me again. I have such a question. With all these new features, what about plans to simplify and sugarize the widely used old classes like standard map, unordered map, which really lack a lot of functions implemented in different libraries and languages, like contains or take, that we should implement manually each time?
Well, there is STL v2 upcoming, and if you don't like something in a map, you can submit a paper.
Make a proposal.
Right, because absolutely. If there is something you feel is missing and people not noticing, just put it in a paper and submit it. And again, it might not accept it as is, but maybe somebody else will say, oh, gee, yeah, let's fix that. And there is an opportunity because V2, it's this dream. STL V2 is attempt to fix all of the things which were wrong with STL V1. So please keep adding more stuff so that STL V2 would be, good enough so that STL V3 will not be needed to clean up whatever we did wrong with V2.
Yeah. Okay, thank you. So I suggest we switch over to St. Petersburg. Natalia, can you help me? So just pick the cutest one.
Thank you. A quick question about coroutines. What will it be, stackful, stackless, or both? Thank you.
Stackless?
Yeah. There is two kinds of coroutines. One which rewrites your code. You await something and it converts your code to state machine. And another is, green threads.
Excellent. So why not have both? Because you just mentioned the keyword is that that thing that you call stackful coroutine, if you think what it is, it's actually much more powerful abstraction. It's a fiber, volokno, whatever is the correct term, but it's actually a user mode thread. You can context switch, so it is more powerful than just coroutine. So why choose either or? There are some issues with fibers in terms of platform compatibility, because when people start playing with stack registers, there is some context with threads, and on some platforms people can have issues. I know on Windows there are some problems when garbage collector captures the stack begin, stack end of a thread, and then you switch a fiber. And I heard of rumors that on other platforms, not Linux, but others, there are issues with fibers in terms of compatibility. But still, it's a powerful abstraction, and it's better than coroutine, but there is cost to it.
Isn't it possible? It seems like it would be possible to actually implement awaitable stackful coroutines using the stackless coroutines. Like, you should be able to build a library that would let you.
I don't think so. There are used coroutines are not a replacement for threads or fibers.
No, I agree. But if you were actually using the library to generate green threads and let await do the switching between them,
you can use that. So
so it would look the same as
there are different abstractions, and they can play together nicely. Right. So I don't think there is a choice. Oliver, somehow spaced out, I cannot get the last name, Kavalki. Oh, yeah, Oliver Kavalki, the guy who did Boost coroutines and Boost of context. He is in his spare time working on the proposal for fiber-like things. We just didn't come up yet. We didn't agree on the name, what it should be called. I like fibers, but Oliver wants some other name, maybe protofibers or context something.
Okay.
So yes, both.
Yeah, thank you.
Good. Thank you.
So I think we should get another question from Nizhny Novgorod. Nizhny Novgorod, you there?
Sure, we're here.
Okay.
Hello, experts. My name is Alex. I'm working for itsys, which is a company that develops computer vision algorithms. And you're talking a lot about an ideal world of C++, and we are not living in it. Because we don't only write high-level business logic, but we also write a lot of high-performance machine learning and computer vision algorithms when you have to dig up into the instructions and write optimization for a particular platform. And you can often see a lot of conditional branches in the code which optimize certain parts of the code for a particular platform or use some more efficient things from a particular operating system. And so preprocessor is used a lot. And I want to ask you a specific question. How do modules and C++17 solve this issue? How do we do this without the preprocessor? And how do we incorporate in our work?
I mentioned requires feature of concept. So you are able to annotate functions and they will become part of the overload set or will be removed from it or some other standard term. I don't very well versed with standards, but yes. So there is a way to do equivalent of platform switching on the function level in concept. So it's not in a module proposal, it's part of the concept proposal.
And as some kind of experiment on that, in BoostCMD we use handmade, let's say, concept light emulation, so we can choose, which function should be done in this way or this way, depending on the architectures and whatnot. And we played a bit with Andrew Sutton at some CPP Now conference about, can we actually replace this with, requires SSE2 or requires OpenMP, whatever. And well, it was correctly, dispatched. So I think that's a sensible solution. And then, you could actually hide that, you could have your requirements giving you the exact proper information about what kind of code you could write. And if you really, really want, you can just, slap a more generic interface on top of this and just make that running. So it was working with the prototype, so I guess it will still work. So pretty much requires is what you need, yes.
Okay, thank you. So some more questions from here. Natalia. Pick the cutest one.
Joel likes you.
It's like
Hello.
Probably 40 minutes is
My name is Dmitry. I have a question related to reflections about some kind of, compile time reflections, which is important for C++ because we use some crazy macros or code generation on whatever, but the field name is known by the compiler, the class name is known by the compiler, and sometimes we write some, JSON serialization code, and it makes a lot of boiler code. It's very, crappy. And what is the future of this? Something about this stuff? Will it be in the future C++? Thanks.
So there is a reflection study group, and you're right. It's actually very easy to do reflection by the compiler. The problem is that people couldn't agree on how syntactically it will be expressed. But there is hope. I think if you look at the 2016 mailing, you will see there is a paper where co-author is Andrew Sutton, the same guy who was participating in concepts. So maybe that one will go forward. There are some other alternatives, but just because I like that name over there, I think it has a chance to move forward. So again, the question is how to elegantly fit it into the language. It's very doable. It's doable. Just
it's a syntax
how it should
problem.
look like. It's a syntax. Well, syntax and like how to hook up with library, but essentially it's the surface, public surface, how the programmer will consume it. That is where people struggled with. But it seems like it's moving forward.
So there was a funky proposal with members, notation that you can do. Members of some classes, and then you get some kind of compile time iterators where you can iterate over every members of the type and so on. And then you get stuff like name and type that you can apply to this iterator, so you get the information. There was another one where you can basically just say, if I have a structure S, I can write S ... and I would just, unpack all my members without knowing them and so on. There is a lot of variations. There is a lot of way to express the issues. I think we have a consensus on the fact that it's required. It's a common demand, and it's more like, how should we present it to the users? So I think there is more than hope, but it's more like, choosing the correct interface. So we are past the fact that it's a recognized problem. So which is usually a good point to be.
And there are proposals active right now in place, and they're fighting. So that's good.
There was a big problem with concepts too, because they failed to go this standard just because I think there was no common understanding about how it should look like.
So I'm going to repeat this one because guys who are really looking at us in the recording or like watching us online can hear that. So the thing was, there was also the same problem with concepts, I believe. No.
It was different. It was a problem of, it was too huge. And people actually noticed that it's not, it's not normal that for conceptifying STL, we need more entities than the number of entities the STL is providing, So that was the actual issue. Something was wrong into the expression of the issues. So I think it's a bit different.
Yes, because it's made into the standard, and then it was removed by the authors of the proposal because they felt it's wrong. Whereas with the reflection, there are proposals, but there is no agreement on which one, should go forward.
Okay, thank you.
We have a very interesting and popular question from online chat. Ilya.
Hello. Many people in the online ask such question. Modern servers have multiple CPUs in them, and modern CPUs have multiple cores. But STL algorithms are still supposed to be executed sequentially. Are there any plans to add parallel algorithms or multi-threaded algorithms to STL?
There is this executor proposal that just supposed to do it.
Technical specification.
Technical specification, sorry. Oh yeah, true. So
there is a motion to put it into the standard 17.
So you are supposed to be able soonish to just say to STD transform or to STD whatever algorithms, okay, and I want you to run in this kind of context, like with multiple threads or multiple whatever. And that gets to a technical specification, and as Gor says, there is motion to put it into the standard. So it's definitely happening. Maybe in 17, I don't know, depending on what happens next week. If it's discussed, I'm not sure. Is it in the agenda? I don't even remember.
It's in the mailing.
Yeah, okay. So it will probably be discussed next weekend, so we can soon know what will be the status. But that's something which is, the executor proposal get over a lot of revisions and addition by different actual parallel system vendors, and so it's actually quite, it's there. We just have to know what will be the status after Jacksonville, but it's already a technical specification. So,
and there are several implementations already out. Good.
Okay, thank you.
Hi, my name is Roman. I am from Kaspersky Lab. What do you think about integration of coroutines to parallel TS and file system TS? Thank you.
So I think after coroutines are in the language, we are already trying to figure out the best way to integrate it with libraries. There are some ideas how we can extend the completion tokens, which are in Boost as IO, to enable hookup, efficiently with coroutines. And currently, file system will be accepted as is, and it will be extended in the future with async stuff. When proposal will be. But right now, file system is likely to become in the standard as is. Did I answer the question? I think I forgot the question.
Integration about file system and coroutines.
Probably
in extensions too.
An extension in the future, not in 17.
Okay, thank you. So several more questions from Moscow. Moscow? You there?
On the second row.
Hello, my name is Denis. What is your opinion? Is it probable that something like C# async await would be implemented like a language feature? I mean, async await is the language keywords, but boost coroutines is completely library solution.
Or
I'm just wondering how it will be look like.
So I think if you look at the coroutine proposal P0057, it looks very similar to C# await, but way better. And boost coroutines are actually built on a very powerful abstraction of fibers, and underneath there is the boost F context. And you can build more stuff with it, but it has different properties. And potentially fibers in whatever name will get into the C++ library as well. So you will have both, and you can mix and match however it fits your problem.
Okay. And we're actually running out of time. So I guess that was the last question. So thank you all for being here. So what do we have now? Now, first of all, we have presents for those who have asked the best questions. So, do you want to,
How do you want to solve it?
So that's a difficult problem, huh? Okay, you know what? They'll just have their conversations there and figure out which questions were the best one, and meanwhile I'm gonna to brag on for some more. So tomorrow and the day after tomorrow we're having the C++ Russia conference, and we're going to talk more about C++ there, much more. So come there and enjoy it. So I guess it's time to say goodbye to our guys in Moscow and in Nizhny Novgorod. So goodbye, Moscow. Thanks for joining us.
Thank you.
Yeah, and goodbye, Nizhny Novgorod. Thanks for being with us. Already left, huh? Nizhny Novgorod, are you even there?
You're not getting the gift.
Okay.
Yeah, we are here. We are waiting for prizes.
Cool. Out there waiting for prizes.
Just one
Moscow
prize?
and Nizhny Novgorod, you figure out your prizes yourself.
4 or 5. Oh my God. So far we have one.
Okay.
Please
then
go
goodbye.
on.
Well, it's the one about crazy things that crazy proposals which come to the committee. So I think.
So it was in Moscow. Be sure to give him something. Okay, so we need 2 more actually, at least. So then, after we're done here, after we're done with the presents, and by the way, when I'm asked to, pick the best question, it's also very difficult for me, so please bear with it. So, once we're done here, you're all invited to join us at the Pirozhki eating party, which is kind of an after party for this event. And there you can, catch these guys, ask your questions. Just, make sure that it doesn't, go on all the way till midnight, because they want to sleep before the event that's going to take place tomorrow. So I guess that's it. Your time is out.
We have second.
Okay, cool. Another question. Yep.
I was intrigued by the one about how you deal with shared state with using only futures, to which my answer was you can't.
So it was like 5 threads something, and it was from Nizhny Novgorod, no? Or from Moscow?
I don't remember where it was
or
from.
It was here. So, yeah. We don't remember who has asked this.
That wasn't Nizhny Novgorod, definitely.
So it was Nizhny Novgorod. Cool.
That wasn't.
Okay, so maybe we should give something to the guys here, huh?
And exactly, because we really like the sentiment of getting rid of the preprocessor.
Yeah.
Even though it won't happen, but we like the way you're thinking.
Yeah. I think it's so.
The preprocessor question about slow IDs. Yeah, that's you. That's you. Cool. Do we have more presents, by the way? Yes, we have. Should we give them out? We need to come up with another person. Okay, truth be told, we don't really remember the question because that's how it goes when you answer. They're just coming at you and you're answering, and you cannot remember what it was afterwards. We have a cute girl here. We might give a present to her. She did ask a question, by the way. Well, thank you all for coming here, and let's go enjoy. Well, you want the last one? Oh my God, I forgot the most important part. So we have presents for you too for coming all the way here into cold Russia.
Thank you for coming.
Yeah. And now we can go. Thank you all.